So this is a Matlab based simulation intended for the sampling and aliasing for an audio signal. So initially I use an audio read file and I select a random audio file. Herein it's anwarmasood.wav. So I would extract a vector y and a sampling frequency fs. In the next line, I would need some further information about the audio file, so I would use audio info and the same file. So this is going to give me the duration of the audio file and whether it is mono or stereo, that is the number of channels, sampling frequency, and some other parameters. Next, for the time domain analysis, I'm generating a vector t, that is for time, which starts at 0 and terminates at the info duration. So the duration that is available in the file info would be extracted out, right? Whereas the sampling time is simply 1 over fs. Next, the time index is adjusted, and as a first step we have time domain plot. So I have set figure 1 subplot 211 plot t with respect to y. Furthermore, I am also interested in the Fourier transform of this signal, right? So I would do a fast Fourier transform, and I would set the total number of total samples from the info file which is already here, and I would do this process to achieve a single side spectrum. And for that we would have the frequency domain plot, which is figure 1 again, and this is subplot 212, and I'm going to plot f, that is the single side spectrum, the right side spectrum, and p1, which is over here, right? So we have a time domain plot and a frequency domain plot. Next, I have set a keyboard just to visualize the data in time domain and in frequency domain, and then I would play the sound which is there in this file. So let us run this simulation. So this is the data which is available in the info file. So over here we have the time domain plot, which is roughly 9 seconds as mentioned over here in the duration 8.83, and we have the total number of samples, sample rate given here. Now for the sample rate it is set to 4800. For the sampling rate, observe that the single side spectrum is band limited to around 24 kilohertz. So as per the Nyquist criterion, the sampling rate is set to 48 kilohertz. Moreover, note that since this is an audio file, so our content which contains information would be limited to around 4 kilohertz, while all of this is just appearing from the noise. Now let's play the sound.
अनवर मेरे वतन के जवानों ने आजकल इकबाल की खुदी को भी सेल्फी समझ लिया.
This sound is basically a poetry by a Punjabi poet, Anwar Masood, which is sampled at 48 kilohertz. Let us look into the effect of aliasing or undersampling on this audio file. So I have set two variables, one is q and one is p. So if q is equal to 1 and p is equal to 1, so the sampling rate would be as is, which is 48 kilohertz, right? But right now what I am interested in doing is I want to downsample it. Herein I am downsampling by 2, that is I have set p equal to 2. By this what I mean is that for our sampling pulse train, which is represented over here, for the first 20 say milliseconds, so the first sample is available over here in 2 milliseconds and 3, 4, 5 and so on. So by downsampling by the factor of 2, what I have done is I would skip this sample and extract this, the second sample, and put it in the place of first sample. Then I would skip that and put it in the place of second sample, and so on. So overall duration would be reduced to 10, and in this way I have skipped all of the odd valued samples. So let us look into the example again. Right, so as a first step, I would resample the y right? The Q is set to 1 and P is set to 2. So I would play the sound. Originally the sound was for 9 seconds, so now it would reduce to roughly around 4.5 seconds.
अनवर मेरे वतन के जवानों ने आजकल इकबाल की खुदी को भी सेल्फी समझ लिया.
I hope Professor Anwar Masood doesn't mind this kind of processing. Anyways, let's move on. So in line 35, I would reschedule them as per our original time frame. By that, what I mean is that I would take this sample and put it's in original position. That is 2 millisecond. So this would be 4, this would be 6 and onwards. In the meanwhile, the missing sample would be interpolated. So based on this value, it would be interpolated, right? So there will be some interpolation. Mind you, this interpolation would not exactly be like the original data. So let us go back to the simulation setup. So again we have resampled it. Now I have put P here first and then Q, and then I am going to play the sound.
अनवर मेरे वतन के जवानों ने आजकल इकबाल की खुदी को भी सेल्फी समझ लिया.
So you would not have observed a lot of difference between the two sounds. Let us look into the reason why is it so. So in this plot, the blue line is showing the original data, whereas the red line with circle indicates the resampled or recovered signal. You can observe that the red line is almost following the blue line. Therefore, there is not a lot of difference, and we have almost captured the information that is available in the audio. However, please note that we have less number of samples. For example, initially we have 2 samples for the blue line, but for the red line we have only 1 sample, right? So the number of samples have been reduced to 2. Also note that undersampling by a factor of 2 would constitute to the sampling frequency, which is around 12 kilohertz. Originally it was 24 kilohertz, now it will become 12 kilohertz, but 12 kilohertz still contains all the information. So this is the reason that we do not lose a lot of information. Also note that the resample function is actually performing an anti-aliasing filter. So the behavior of that filter is expressed in figure 3, which is over here. So we have the magnitude response and the phase response versus the normalized frequency. Note that the anti-aliasing filter has suppressed the magnitude at high frequency contents. To experiment further, let us downsample further by a factor of 20 and see the behavior. Well, that was quick. Now let us move towards resampling to the original time frame.
अनवर मेरे वतन के जवानों ने आजकल इकबाल की खुदी को भी सेल्फी समझ लिया.
Now we have significant difference between the original sound file or the sound which has undersampling or aliasing. Now again the same plot in which on the x-axis we have time and on the y-axis we have amplitude. The blue is for the original while the red is for the sampled or recovered signal. So you can notice that we have lost a lot of information, especially at the edges. Note that in this time frame we only have 6 samples for the recovered signal. So if we downsample it further, we will lose more information in the audio signal. The anti-aliasing filter response for this setup is represented over here in figure 3. Previously the anti-aliasing filter undersampling by factor of 2 was suppressing the normalized frequency in around 0.5 to 0.6 range, but for the undersampling by a factor of 20 it has considerably suppressed the frequency contents starting from rather a low normalized frequency.